Good evening. So I guess we should have changed the name rather than processing money in the cloud, like giving away money in the cloud, so we would get a little bit more participation, but I guess too late to change the name. I was trying to convince myself that it's not a bad thing to have this session at the end, because usually they keep the best for last, but that's okay. Next year we're going to be the first session. We're going to be keynote speaker. So this is about our journey that I think some of you guys were part of it, of how Radian as a company that might not be known for innovation in technology kind of took the burden of be a pioneer in mortgage industry to start leveraging cloud and think about the capabilities that we have to align it with the cloud. So we're going to go through the journey. Hopefully you guys relate to some of the stuff that we have. I have my friend and one of our partners, Shri, going to be here to participate and actually give a presentation in a couple of slides, and we'll open it up to questions. So let's start. Let's talk about our business. So Radian, we're in the mortgage industry. We insure mortgage transactions. Not the sexiest thing you can imagine, but hopefully we're going to talk about some aspect of this that is going to be interesting. And we are in a B2B model. We have 5,000 customers that they're all actually financial companies. And we started a journey a couple of years ago to start thinking about how we can enhance our capabilities to be able to stay competitive and not only actually change the mortgage insurance industry, but start thinking about how we can actually contribute to the mortgage industry as a whole. If you look at our process model, is fairly simple. We look at loan data as our raw material. Raw material to be able to initiate the underwriting of mortgage insurance, the raw material for actually managing and servicing of that information, and ultimately the loss management and claims. But there was a shift that it's actually kind of forced us to be able to think about the simple business model a little bit different. The challenges that actually kind of forced us to think about this, there was a redundancy of this raw material across our enterprise. And this is a microcosm of basically the same processes across the industry. Each department, they're actually looking at aspect of this data in their own silo view of how they want to process that. And because of that, we have significant amount of redundancy around this data. From a protecting and security, obviously, the more you create that redundancy, you create significant amount of inefficiency to be able to protect this actually redundancy of data. From a data quality perspective, it's really hard to maintain a high level of accuracy in terms of the final version of data, which data has been replaced, the timing associated to that. So we create a significant amount of overhead in our applications to be able to manage that. It was really hard to adapt the business model and the data to actually take advantage of some of the new changes in the industry, and in certain situations adopt the compliance paradigm that actually existed. We spend thousands of hours sometimes to absorb some of these changes across our platform. And agility, this morning the whole paradigm was around agility, and that was another challenge that we have, that our speed to be able to absorb these changes, it wasn't where we wanted to actually to be. And if you look at the shift in the market, very quickly we started being swamped, as you see, by processing this data to be able to take a subset to make it actionable. Originally, we were actually processing for $1 billion of insurance, a new insurance written, as you see, very small data set. As we went through processes that required a lot of images, a lot of documents, there was a significant burst in terms of the data that we had to process. And majority of that data was in an unstructured format. And that created a significant challenge for us. So, to a degree, we started looking at cloud, not primarily around some of the natural tenets of cloud, which is elasticity and actually cost aspect of it. We really needed a platform to be able to deal with some of these complex processes. Capability was the #1 driver for us. So very quickly, we actually looking at how and why cloud is actually could help us. Obviously, in a financial industry, we had to be very, very considerate of the security aspect of cloud. So we spent significant amount of time talking to our customer, learn from companies like CIA and NASDAQ and actually the big guys that they solve some of these problems to be able to make these not only about making cloud secure, but make Radian even more secure than what we had in our current state. And obviously, the last piece was our ability to absorb and take that shift. We are not a startup company. We are not we are not some of these new age companies that they can really quickly experiment. We had to make a major shift from a cultural perspective. And for us, it was really important to see, can we do it? Is it feasible for an organization like Radian? So we started looking at all of these dimensions, and little by little start to actually looking at cloud as a core component and core strategy, both from an IT and from a business perspective. But that wasn't enough. That wasn't enough. We needed to actually make this a little bit more structured. We need to actually have more discipline, more principle in terms of how we're going to take this journey. So we started thinking a little bit around some of the principle that would help us to go down this path. We started with the cloud strategy. That wasn't kind of enough. We needed to get a little bit lower. Then we said, okay, what in the cloud strategy we need to do? Do we need to go multiple cloud? Can we actually looking at AWS? Very quickly, we align our strategy with AWS First. Being in an insurance company and not being in the business of actually technology, it was really important for us to align ourselves with a set of actually principle and technology that we could culturally adapt to and not go through a rapid change from one technology to another. So we went AWS first, and even more deeper from an architectural perspective, we started putting some principles in place. And you can actually read some of this stuff. We don't have to go through that. So walking through some of the components that we put in place and make it relevant. So let me just walk you through our business process and how basically the transaction they're coming in. You saw originally we were actually processing a lot of structured data. That was the amount of data. It was small. EDI transactions, XMLs coming in, very nimble. Our responses to some of these requests, they were sub-seconds to be able to actually initiate that. As we started shifting to the left, as you see, we started receiving a lot of images, a lot of redundant images. We are actually processing over 1 million pages every 2 days. And all that data in those documents are relevant for an underwriter to be able to actually make a decision. So very quickly, processing these unstructured data, it started impacting our timeline and turnaround time. So we started looking at capabilities that we could leverage and create a proxy, create actually a wall between our processes and our data. Rather than absorb some of these unstructured data, we started leveraging machine learning and heuristic, extract significant amount of this data and put it into unstructured format. That wasn't enough. we had to actually now deal with this significant amount of data, which the consumption of that, it was different. Some of our transactions, some of our business, they wanted to see data at the summary level. Some of them, they needed to process the variation of that data because they were looking at investigation. We had use cases that required to look at data from a trending and timeline perspective. So what we did, we started actually storing all the data in S3, and the S3 first, it was one of the principles that we pulled together. So data stays in S3, and every single endpoint and consumption endpoint, it's customized for the user that we have. Some of the consumptions, they're sitting in the Dynamo. Some of them, it's going to be actually cached in Elastic Cache. Some of the endpoints and this data, it's going to be processed in Redshift. So it depends on the consumption layer. The same data, the same version of data, it's actually started to reshape itself around some of these endpoints that we have. So this is the high-level architecture that we put together. Obviously, as we talked about, 5,000 customers, they send data in multiple formats. We have channels, electronic channel, email, web, FTP tapes. This data, they are coming in. We provided components that actually plug in to some of these streams that we have. The data come into S3, the data gets processed, go through a complex workflow to actually extract the data, prepare it, and actually post it into some of these endpoints that we have. We have prepared a little bit of a simulation for you guys to actually put this entire picture into a real-life flow. We took the data from our actually transactional system, and we are simulating millions of pages of documents to go through our process. So Shri, it's going to help us kind of take a look at that, and I'm going to give some comments around how this process works. It's probably a separate page.
It's not going on the mouse on that screen or what?
Two pages.
Oh, I can't see the mouse. Oh, there it is. Huh?
Take that from the full page. Here it is. So this is 2 weeks of data going through this actually architecture from and you see how visualization, it's actually helping us to understand the bottleneck. These are millions of pages going through this process. The extraction happens. You see bottleneck. These are some of the areas that they had to tune the system. They are actually, I think, just make it here. This area is when the system wasn't processing these stuff optimally. We move forward. You see some of the enhancement and flow of information. So this is the actual data, live data, going through the system. We took a snapshot of that. You guys see actually the bottleneck of these transactions. So we try to make mortgage application processing a little bit sexy by simulating it. It's not that cool.
So switch it back.
And today, with some of the announcement, we have opportunity to be able to take advantage of, for example, the Lambda, the features to automate some of these processes faster and kind of elastic, better than what we have. So let's move on. So if you look at our architecture, as we talked about, the raw information, it will be stored in S3. We have a transformation layer that right now it's actually transforming this data for different consumption. That data is either persisted in Dynamo or Redshift from an analytical perspective, and we are actually indexing every single transaction that they are coming in. We are indexing the raw data. There are multiple formats of that different level actually of the different formats of information from different MISMO, actually XML types to, we have data that they're coming still in the X12 format, the old EDI. We are indexing those. We have actually indexed that they're at the business domain model. This allows us to be able to search the data lake based on either the raw data and the enumeration and actually semantics, and at the same time be able to search at the business domain model level. And we are pushing this data to our system of record for consumption. Obviously, this data is not persisted. The pointer to this data is there that allow us to maintain one version of this data. And from a security perspective, Shri is going to touch on how we are actually taking advantage of the encryption and tokenization to keep the data safe in those repositories. So, Shri, do you want to?
Yeah, thank you, Sufi.
Thank you.
Right. So how many of you are actually building native Amazon applications? Can you raise your hands? Okay, so I used to be at Amazon, and the primary reason I got out of Amazon is to really enjoy the pleasure of building native applications. And today's announcements, if you've been following through, they're really making this so much more interesting, right? Changing the paradigm in the way you actually think of building applications. At services like Lambda, you don't have to worry about setting, as easy as it was to set up infrastructure on Amazon. It is still time-consuming, painful, going through different environments and all that, right? So the way I've structured this, the next few slides is really trying to talk through the challenges we faced as we went through this. And I'll start with the, and I see the challenges as opportunities. So our number one challenge is working for a boss that, designed latches for Apollo space mission, full of machine learning, and wake up all the night and thinking about new ideas. So every day, it is a new day with a new challenge, right? And I'll give you one example. In these challenges, in spite of us having, working with the Amazon, solutions architects, and we, and I strongly, suggest that if you are going through a journey like this, that we established a steering committee. Every week, we have these discussions to make sure that we are designing this properly. And all of a sudden, we are kind of back to the drawing board today. And we were having one meeting with Amazon, and we're talking about this paradigm of having S3 as an authoritative data store, and then having Dynamo. And the Dynamo team was, was suggesting, in front of Dynamo, you should really have Elasticache as a, so you can get like microseconds latency, which is great. But Elasticache wasn't highly available till about 2 weeks ago. And so I got an immediate question to when was it available? Right? It was available only 2 weeks ago. Then we are 2 weeks late to implementing Dynamo. Elasticache was the comment I got. Right? So it's fun to be in the leading edge and have the opportunity to work with someone that gives the opportunity to try and be really agile in delivering the solutions. So you saw the plethora of solutions, of services that we use on Amazon. And I can say that we pretty much use majority of the services except Mechanical Turk, right? And that there is probably an application for that as well in this, as we look to our future solutions. So thinking about big data, processing a lot of information in the cloud for a regulated industry, customer like Radian, involves really addressing security, right? So what looked at, I'm kind of talking to security at a very high level here, but fundamentally you look at it from how people access the information. So really building that identity and access management layer, which I'll touch in a little bit more detail, and then creating a demilitarized zone, both not just protecting the inbound traffic, but also protecting the outbound traffic. So when you're using application services like S3, SQS, SNS, it is also important because they're all internet-facing services. So it is important to control what can flow out, right? So creating that network DMZ layer to give you that level of protection. And then from a storage protection perspective and a server protection perspective, the storage protection, making sure that you're encrypting the data at rest. Now that, one of the challenges we faced in terms of encrypting the data at rest is that, we have, I think it's this slide, right? There is a very processor-intensive and storage-intensive application in terms of taking these loan documents and extracting information out of it. And it requires a file share. And the rate at which the IOPS and the rate at which we could get that file share to perform was not quite performant enough. And now you try to find a solution that provides encryption at rest for that, for a file share. On Amazon, trying different solutions really did not work. But just to our rescue, right about that time when we were still scratching our head in terms of what to do, Amazon released the elastic block store encryption, which saved the day. So from an S3 key management perspective, we also looked at various options that S3 offers from a server-side encryption perspective and a client-side encryption perspective. Again, when we obviously tried to go after the choice of using a client-side encryption, and in that again, key management, as you may have heard Andy Jassy speak about the challenges of key management, is something we really faced, is because yes, you have a Cloud HSM or a key store, but once you start building a key manager that is highly available, and when you look at rotating keys on a per object basis, it turned out to be a lot more challenging. And again, the solutions are not really quite operational yet, right? So is a temporary thing. We're looking at what we could do, and again to our rescue, it's great to have the new key management solution, and we're looking forward to definitely going back and trying that solution, right? Again, I mentioned identity and access management. So if you looked at the pipeline slide, the first thing that happens is the applications have a plugin, a .NET Java, JavaScript plugin. And first thing they do is get a token, and only if you are authenticated and authorized, you are able to drop that file in the S3 bucket, and it kicks off an itinerary by putting a message in the queue for the workflow to pick up and go through the rest of the transaction. Now, the Amazon STS offers the token service to be able to consume Amazon services. There are other applications that use this service. So we wanted to build a token service that actually vends internal tokens to be able to use the web services-based, service-to-service authentication-based tokens, and use the Amazon tokens. Now again, this is an area where it is still quite a challenge with Cognito offering new services every day. But this is one place where we have to still build our own solution. And I think it would be really nice for Amazon to come up with an authorization, auth as a service, if you will. So the service accounts can be as easy as using Amazon STS, right? Now, one of the biggest, challenges and again opportunities is the way you deal with the security team in the organization. I think the idea every time we have to we have to, the experience that I have been at many customers is always, you're on either side of the table. But I think it is very important to remember that end of the day, like the customer centricity that Amazon has, both the dev team and the security team are really focused on the customer, right? The reason they are presenting that gate to you is because they want to make sure the end customers are happy with the solution that we are putting in place. So what it takes from a DevOps, or I would extend that to like a DevOps sec perspective, is really showing them a picture of how your solution is secure. And this is one example of the entire, like the high-level flow, but this is breaking down into multiple pieces and showing how at every level, whether it is the STS temporary token or the real credential, and making sure, again, you can go to the next level to show how links are encrypted, how access control is encrypted, how you can really prove that the right people are getting access to the right information, and you back it up with the proper logging solution just to make sure that everything is kosher, helps everyone in the company as well as your customers feel good about it, right? So that's a good paradigm that I would suggest working through. Then after you build all this, you're continuously improving, and you have to put together a mechanism in place that will help you do continuous build, continuous integration. And as Sufi mentioned, you all talked, you saw all the new innovations coming up in this space. At first, when you're looking at it, I'm sure as many of you, if you have looked at it, you'll face the same challenges between CloudFormation, OpsWorks, Beanstalk. Where does this whole pipeline fit? What is good? Where? It's not an easy answer, right? You just cannot say, okay, this is the best practice around it. But we're hoping that with the new code deployment services and code commit services, that some of this will improve. And the primary reason we want to do this is because it improves the agility with which you can roll out code. It gives you the right metrics that you can measure, and you know that you are improving. And we have internal metrics like that where the deployments went from hours to minutes, and we're constantly trying to change the rate at which we want to really try to bring it down to some seconds if possible, right? And perhaps even if we move to the to Lambda, it's there's I don't know what deployment means there. It's just push a button and then you're ready to start using it. So, yeah.
So we talked about the technology, but I think to a degree we feel responsible a little bit to help our fellow financial industry kind of participant to kind of learn from some of the lessons that we have. And we want to actually focus the rest of the presentation not around the technology lesson learned, but around some of the principal architectural and cultural lesson learned. Coming out of a legacy mindset in terms of software development, SDLC, write requirements, do the development, test it, user acceptance testing, and then ultimately actually move it to production. With our modernization, we very quickly learn that we have to look at the life cycle of software similar to how the supply chain and manufacturing, they looked at it and became successful. In manufacturing, for hundreds of years, they were looking at projecting what actually the demand going to look like. Systems, ERP systems, MRP systems, huge calculations to looking at trends and say, okay, this year, this is our demand going to be, and we're going to actually start stacking up our inventories. We're going to tweak our processes. We're going to get everything ready to be able to satisfy that. That mindset changed 40, 50 years ago when they started looking at a Kanban process, pull versus push. Rather than projecting what the demand going to be, they are looking at coming backwards from the demand. When they receive an order, they figure out, what should I do to satisfy that? What is the last thing I should do to be able to satisfy that order? They do that. Then to satisfy the last step, what is the step prior to that they have to do to be able to? And they come backwards. So apply the same principle to software engineering. What is the last thing that happens in the life cycle of development? Deployment. Deployment is the last thing we do. But in the process, but we should start from that as the first step. If we want to actually be a pull process, we experience that the first thing we have to do, we have to look at getting our deployments, figuring out how to move things. What is the step before deployment? Testing. We need to figure out, we still don't know what our requirements are, what we are developing, but we need to start thinking about how do we automate our testing? What is the mechanism of testing that we're going to put in place? Then we're going to come back into development. So this is a paradigm shift to be able to bring the agility. And that's why in the last page, we were thinking about changing the notion of automation. In a typical legacy mindset, you say, okay, we're going to build it. When everything is good, we're going to go and automate it. That's not true. Automation is a state of mind. It's a paradigm, it's a style. Is not a state that you achieve. And if you think you're going to build things and then you're going to go automate it, it's going to be too late. Automation needs to be actually adopted on the day one. The processes needs to be looked at backwards. If you don't, you're going to get to some of the agility issues that a typical legacy firms, they fall into. What else? What else from an experience perspective we can actually share with you guys? AWS First Design. That's another actually lesson learned that we had in an organization while we were thinking about moving to cloud. There were significant amount of actually tools and capabilities that needs to actually come together to be able to make this thing successful. And we had a tough time to be able to pick and choose which tools, which technologies. And one thing very quickly we learned, our rate of adoption of tools and technologies is a lot faster if we leverage AWS components. In a typical enterprise like us, we're going to actually cut down the vendor management aspect of it. Contract negotiation, pricing, all of those, it goes away. So the first thing that we put in place as our principle is AWS First. Even if you have to wait, even if you have to actually adjust our sequence in terms of delivery to be able to match the timeline of AWS, we are actually trying to get to that. That helps us significantly in terms of cut down the overhead of dealing with multiple technology vendors and just kind of focus on delivery. The second component is, and this is the term that actually we stole from one of the TED Talks, more data is better data. Cloud strategy always starts data first. Typical companies, not in the legacy world, they start moving their workloads to the cloud. We learn for you to optimize your workload, you need to have an optimal data structure. Otherwise, your workload is either not going to work or it's going to be suboptimal. So the data-first strategy is something that we adopted. The component that you guys saw with the data lake is where we have all of our loan data, and from that point, all the components that is around the processing of that data, it can easily be moved to the cloud. If we wanted to do that backwards, we would have problem around the encryption, we would have problem around the redundancy of data, we would have problem around the accuracy of data. The notion of more data is better data, and kind of the data-first strategy helps us significantly. Another thing that actually we call it the kind of data to the power of data is the notion of growth in data. Typically enterprises, they get more data, more transactions. We changed that slightly. We put a goal that said we want to actually get to the point that the data about data, it's going to be more important than data itself. So as our data grows in the data lake, the metadata associated to that, it grows. Not only we know about our data, we know the consumption patterns on that data. We know the decisions that are made on the slices of that data. And all of that is represented as data. So our data becomes smarter. Every day, every week, every month, the same data that usually is trapped in relational databases, it evolves. And this notion of growth of data and growth of metadata and data to the power of data, it's another actually paradigm that is really important to take advantage. Before, you couldn't do it. There was no way to capture metadata when the data is trapped in a relational database with a structure. But if your data freely resides in S3, you can tag it. You can have Dynamo tables that actually capture metadata about that data. You can look at the consumption and bring the copies of the data back into the data and create correlation. And bringing this powerful paradigm to transactional system, it's significant. Typically in the reporting and analytics, you have those structures, but we brought this power to the transactional system. So when the claims operator will pick up this loan data to be able to figure out what happened in the transaction, they have every dimension and aspect of consumption of that data in the upstream with the underwriter. They can replay that information and be able to recreate the situation that they actually had 2 years ago, 3 years ago, when this thing was originated. Another concept is this notion of reuse processes versus reusing data. This is another lesson learned from supply chain and manufacturing. 60, 70 years ago, manufacturers, they realized moving raw data is expensive. So they started looking at building CNC machines that the raw data, raw material would stay stationary and these processes, they would come. The process to drill a hole, the process to paint the machine, and they would actually keep the raw data. We are learning from that. Our data stays in one place. In a traditional legacy, there were two reasons that you move data. You move data to give access, right? This is my system, that's your system. So if you want to get access to that data, I'm going to give you that data. I move the data. The second reason to actually move the data was the only way you could change the shape of the data is by moving it. The data goes from the transactional system to the ODSs, from ODSs to the data warehouses. Why from ODS to the data warehouse? Because we were actually going from a relational structure to a star schema. You had to change the shape of the data. That's why you were moving the data. In the current model, you don't need to do that. You unleash an EMR job to go process your data and actually create a column-based structure. On the same data, you can actually unleash a Lambda job to be able to calculate a specific unit and give access. So this notion of reusing the processes and leave data alone to be in the same spot is significant architectural improvement that brings a lot of simplicity to what actually we put together. Another concept that is important is notion of information security versus boundary security. Put cloud aside, if you look at enterprises, the distribution and redundancy of data has created significant amount of overhead in terms of managing and securing that data. Every system has the same data. If you have customer information, probably customer's social security number is the unique identifier for the customer. And if you have 20 systems, that unique identifier is distributed across the board. And that's why you have to actually manage and secure those systems with the same level of intensity. In the new model, centralization of data, it's going to actually separate that. We created a pattern called the NPI vault that allows to take that data and have one copy of secure data. And we put security around it, we're protecting it, we make sure we have traceability around it, and the rest of the systems, they only have reference to that data. So that's an important actually paradigm to be able to protect. The notion of centralization of actually the key information, it's really important. We talked about automation as a style, and not an end state, is another concept. To be able to, the first thing that you start with, automation comes in. How can I actually avoid doing what I'm doing? Before even you write one line of code, you need to actually have an automated process to deploy. That's very important. And just one advice, get used to doing and redoing. That's just nature of the beast. We are not in the legacy enterprises used to dealing with change and invalidation of our decisions. We would buy a system, and for 6 years, we would enjoy taking advantage of that. Right now, we build one in 2 weeks. All of our designs are invalidated. Even the picture that we put out, we wanted to actually put a line on top of that. I said, don't try this. It's changed. It's not valid anymore. We got to get used to it. We got to get used to doing and redoing. And that's the only way you're going to be successful. Today, I forgot, one of the speakers talked about that. If you don't rewrite your software, they will rewrite it for you. So we got to make sure that we rewrite it ourselves. So that was kind of the summary of our journey. That was some of the important lesson learned that we had in terms of dealing with the shift to cloud, not as a pure IT strategy, but a game changer of how our organization, how our enterprise, it's going to go from an insurance company to actually a technology company that happens to process insurance transactions. And we think that's going to actually get us competitive. We think we're going to not only be competitive in our domain and market, we're going to be able to actually get some of these experiences and lift the mortgage industry, hopefully, to a better place and a driver in financial industry. So that's the end of our presentation. I'll open that up to any questions that you guys might have, and hopefully we have some experience and answer to your questions.